Hello everyone, welcome to my presentation. Today I'd like to share some knowledge of virtual and augmented reality with you. Virtual reality is an environment generated by simulating the real world and existing inside a computer. Users do not need to use a mouse or keyboard, but interact in a natural way. In a virtual reality environment, users can experience visual, auditory, tactile, and other senses, allowing users to interact with the virtual world in a highly immersive way. Users usually experience 3D virtual space through devices such as HMD and handheld controllers. The primary purpose of VR is to create a virtual world that gives people a real experience, providing multiple uses such as learning, entertainment, and exploration. The differences between AR and VR is that VR completely replaces the user's real environment, while AR superimposes the virtual objects on the real world. And the differences between VR and MR is that MR is a combination of VR and AR, allowing virtual objects to interact with the real environment in real time, while VR is a completely virtualized closed system. And there are two significant milestones of VR. The first one is 1968, Ivan Stirland invents the Sword of Damocles. The other one is 2012, Oculus Rift, launched on Kickstarter. The Sword of Damocles was the first HMD, which connected the device to a computer instead of a camera for the first time. Although the device was bulky, it opened the way for virtual environment exploration and combined several important elements of virtual reality: stereoscopic display, virtual image generation, head position checking, virtual environment interaction, and model generation. It laid the foundation for VR technology, proposed the core concept of immersive visual system, and had a profound impact on subsequent HMD technology. Oculus Rift is a cost-effective head-mounted display designed for video games. It has two eyepieces, each with a resolution of 640 multiplied by 800 pixels. After the vision of both eyes is combined, it has a resolution of 1280 multiplied by 800 pixels. It also has a gyroscope-controlled viewing angle, which greatly enhances the sense of immersion. Its successful Kickstarter crowdfunding has aroused widespread attention to VR. It has promoted VR from scientific research to the mass consumer market, and prompted other manufacturers such as HTC and Sony to develop competing products, which has set off a boom in modern VR technology. And the next one is how is VR applied in entertainment. The first one is games. VR games allow players to be fully immersed in the virtual world, providing an unprecedented interactive experience. Players can control game characters through body movements, which increase the realism and the participation of the game.
Hey, you! Finally awake. God.
We're going. Come on, dude. Go, man. Freaking go.
Quickly, follow me!
All right.
Looks like he's gone for good this time.
This is cool.
The second one is 3D design. Combining VR with software such as Unity and Blender can design the action keyframes of 3D objects more intuitively and naturally, improve generation efficiency, and reduce certain design costs. third one is virtual tourism. Through VR technology, users can visit places of interest and natural landscape around the world without leaving home. This not only saves time and money, but also allows people to experience places that are usually difficult to reach. The last one is concerts and performances. VR concerts and performances allow audience to watch live performances in a virtual environment, as if they were at a concert. This experience not only breaks geographical restrictions, but also provides a more personalized viewing angle. And next, I will show you the three types of VR displays and how do they function. The first one is head-mounted display, or HMD. The principle is to magnify the image produced by a small 2D display through an optical system. Specifically, the light emitted by the small display passes through a convex lens, causing the image to produce a distant effect due to the refraction. This effect is used to magnify nearby objects to a distant view, achieving the so-called holographic vision. The next one is cave automatic virtual environment. The cave technology that creates a three-dimensional virtual environment based on multiple flat display surfaces, such as walls, floors, and ceilings. By combining 4 or more projection screens in a closed space, the cave system allows viewers to immerse themselves in the virtual sense from multiple angles, and they can see continuous three-dimensional images no matter where they look. And the third one is desktop virtual reality. A small desktop virtual reality system based on an ordinary PC platform. The computer screen is a window for visitors to observe the virtual world. The virtual sense is generated using a mid to low-end graphic workstation and a stereo display. Participants use position checkers, data gloves, force feedback devices, and three-dimensional mice or other hand-controlled input devices to realize the important technical features of virtual reality technology. And then is haptic feedback in VR. Haptic feedback refers to the transmission of tactile perception to users through spatial devices, such as vibration handles or force feedback glass, allowing users to feel objects or actions in the virtual environment. Providing haptic feedback can make users feel a more realistic virtual experience, thereby improving immersion. And it can also improve interaction accuracy. For example, when simulating virtual surgery, a haptic feedback can help users judge the amount of force applied. Besides, haptic feedback is crucial in scenarios such as games, medical training, and remote control, and can significantly improve the quality of experience. However, there are some critical challenges in developing VR applications. The first one is hardware limitations. High-resolution displays and low-latency graphic processors are required to avoid user dizziness and fatigue. The accuracy and comfort of controllers and haptic devices need to be improved. The second one is content development. Creating high-quality VR content requires a lot of resources and complex technologies, such as 3D modeling, real-time rendering. It is challenging to adapt content to multiple devices. The third one is high cost and low penetration rate. The high price of VR hardware has limited its penetration in the customer market, thus affecting the return on investment of developers. And lastly, lack of uniformity in technical standards. Different devices and platforms have different technical standards, such as controller input method, rendering interface, and the development and adaptation costs are high. The next section I will discuss augmented reality. AR is a technology that superimposes virtual content, such as imaging, text, or sound, onto the real world. Users can see a mixed virtual and real environment through devices such as smartphones, tablets, or head-mounted displays. AR does not replace the real world, but enhances or expands the user's perception of the real environment. I will give two examples of AR applications. The first one is construction. Architects and designers use AR technology to view and modify building models in real environments. For example, through AR glasses, designers can view virtual building models on a construction site and make real-time adjustments and optimizations. It can improve the accuracy of design and construction, reduce errors and rework, and improve work efficiency. The next is tourism. Museums and tourist attractions use AR technology to provide visitors with an enhanced guided tour experience. For example, visitors can view virtual reconstructions of historical sites through AR applications to learn more about the background information. It enhanced visitors' experience and engagement, providing more educational and entertainment value. And there also have some challenges and limitations of mobile AR applications. The first one is hardware limitations. Mobile devices have limited processing power, making it difficult to achieve high-quality AR content rendering. Battery life is insufficient, and long-term use of AR applications will quickly consume power. The second one is environmental dependence. AR applications requires good light and clear environmental features such as wall or plants for identification and tracking. Low light or textureless environments will affect the experience. The user's lack of stability in holding the device may cause tracking loss or screen jitter. And the next is development difficulty. Developing high-precision AR applications requires complex SLAM technology. Different devices have different standards for AR support, and developers need to be compatible with multiple platforms. The last one is user experience. Users may experience visual fatigue or hand fatigue when using for a long time. And next I will show two popular AR headsets. One is X-Real Air 2 Pro. This helmet is known for its lightness and high image quality. It uses a Sony micro OLED screen, which provides a high refresh rate of 120 Hz and excellent color performance. It can also be connected to smartphones, PCs, Macs, game consoles via USB-C or matching X-Real Beam wireless accessories to achieve plug-and-play with virtual screen. It also provides electrochromic technology, which can adjust the transparency of the lens to adapt the different indoor and outdoor usage environments. And the other one is Microsoft HoloLens 2. Users can interact with virtual objects through natural gestures such as finger tapping and dragging, and support high-precision hand tracking. Compared with previous generation products, the field of view is larger, providing a more immersive AR experience, and it is widely used in medical, construction, and industrial fields, supporting enterprise customized development. That's all. Thank you for listening.